Hello dear students. In the previous class, we were discussing about the fundamentals of organic chemistry, like the classification of organic compounds, what is homologous series, what is functional groups, and today we are going to learn how to name an organic compound. That's what we call nomenclature. Initially, there were very little of organic compounds which is isolated and which is having purity. For example, urea. Urea has been isolated from urine. Urea crystals are isolated from urine, so it has got a name urea. And many other organic compounds. There is a class of compound is what we call barbiturate. They have got the name according to the whims and fancy of the one who discovered. Because the one who discovered was having a girlfriend whose name is Barbara. If it would have been in India, the acid would have been something like Lakshmi acids. So, initially the organic compounds are named as per the source we got the compound or according to the whims and fancy of the one who discovered it. We have few more examples. Like formic acid, acetic acid and glucose. Now the question is, given the huge number of organic compounds, is it possible to name all of them based on their origins? What about the names of the synthesized organic compounds? Can you write the structure of the compound given its common name or the tribal name? So these are the questions we are going to address now. So there is a huge number of organic compounds. If you take chemistry, in chemistry there are so many compounds. They are classified as inorganic and organic. Inorganic, there are limited number of compounds, whereas organic, millions of compounds. Day by day, so many compounds are getting synthesized. So how do we name this compound? And you can't go with the source of the compound or the one who discovered it always, because the same compound could be identified in India, could be identified in US. They cannot have a different name. So let's see. That's how International Union of Pure and Applied Chemistry came into picture. And IUPAC, that's how it is called. IUPAC has suggested a particular method to name the organic compounds. As per the IUPAC nomenclature, the IUPAC name is based on the structure. It is applicable for all the existing compounds. And this particular name contains mainly three parts. They are the systematic name of the compound based on its structure. It has got three parts. The first one is what we call root word. What is root word if you ask? Root word is the basic unit of IUPAC nomenclature, which indicates the number of carbon atom in the main chain. So root word, it could be told like how big the molecule, what is the number of carbon atom in the longest continuous carbon chain in the compound. These are all could be represented by the root word. So Root word is the basic unit of IUPAC name nomenclature, which indicates the number of carbon atom in the, it could be read like this, longest continuous carbon chain. Then next one is we call prefix. Prefix is added before root word, which indicates the given compound is cyclic or acyclic, and it will even again talk about which are the substituents of this organic compound. So a prefix is meant for two things: to mention whether the given compound is cyclic or not, and the second point is what are the substituents in the organic compounds. And the third part is suffix. Just like prefix, suffix is also having very important information. Suffix is added to the root word, which indicates whether the given compound is saturated or unsaturated, and what about the functional group of the organic compound. So what is the most reactive part of this organic compound? So suffix will be there for the indication of whether the given compound is saturated or unsaturated, and the second part is what is the functional group present in the organic compounds. Now let's talk about what is a root word. A root word means it is the basic unit of the IUPAC name, and it depends on the number of carbon atom in the main chain. It could be read like this: longest continuous carbon chain. And how do we number it? It's according to the IUPAC special root word till fourth carbon atoms. Like first, if only one carbon atom, it is meth, 2 carbon atom eth, 3 carbon atom prop, 4 carbon atom bute. And after 4, the Greek number root, it is Greek number after 5 carbon atoms. This is how it comes. So C1, if it is 1 carbon atom meth, 2 carbon atom eth, 3 carbon atom prop, 4 carbon atom bute. So what is the Greek number for 5? It is pent. Hex, 7, hept. What is for 8? Pent, oct. That's how it comes. So if it is 9, nonane. If it is 10, decane. If it is 11, uni for 1. So undecane, dodecane, tridecane, like that it goes. Now let's see next what is suffix. Suffix is added to the root word after the root word. So the suffix gives two information. One is whether the given compound is saturated or unsaturated. Saturated means there is no double bond or triple bond. Unsaturated means there is the presence of multiple bonds. So if there is the presence of alkene, it will be ene. We'll talk about that. And suffix, the second information it is what is the functional group. So this is how the primary suffix and secondary suffix comes. So you could see that if it is single bond ane, if it is double bond ene, if it is triple bond yne, that will be the primary suffix. And secondary suffix, if it is OH or OL, if it is CHO all, if it is CO one, if it is carboxylic acid, oic acid, if it is ester, O8, if it is amine, if it is cyano group, nitrile, that's how it comes. Then what is about the secondary functional group? A secondary suffix is always added to the primary suffix by replacing E. If the secondary suffix starts with vowel, then E of the primary suffix is dropped. If the suffix starts with a consonant, E of the primary suffix is retained. That's how it goes. Now, let's talk about the prefix. The prefix is added before the root word. It could be primary or secondary. Primary will talk about cyclic or acyclic. Secondary will talk about the substituent groups. The substituent groups are given like this. These are few examples. If it is R, means that's how in organic chemistry we represent an alkyl group. NO2 it's nitro, NH2 amino, X means it could be chlorine, bromine or fluorine. It generally represent halo by X. If it is OH, it is called hydroxy. Do you remember what was there in the previous slide? If it is OH, it is alcohol, and if it is a functional group, it is oil. If it is OR, we call it as alkoxy, we call it as ether. If it is CO, we call it as oxo. If it is CN, we call it as cyano. So you will be confused. How can it be? These are the functional groups. How can it be a substituent? We'll come across that point soon. So please understand, if these are the substituent, then this is how these substituents will be named in the nomenclature of organic compounds. Now let's learn about few of the alkyl substituents. Here few alkyl substituents are given and mentioned their names. For example, methyl, it is CH3, ethyl, it is CH2CH3, propyl, CH2CH2CH3. If it is CH and on that two methyl groups are attached, it is called isopropyl. If it is C6H5, if you see somewhere, it is phenyl. If it is CH2C6H5, then it is benzyl. And isopropyl you have seen, if normal means straight chain. If it is a butyl group, you can imagine butyl group, then it can have four different names. If it is straight chain, it could be called normal, for the carbon atoms are in the queue. If it is like one carbon atom and it is attached to another carbon atom, from that carbon atom two more methyl groups are attached, then it is called isobutyl. If there is one carbon atom and three methyl groups are attached to that, then it could be called neobutyl. So this is how this is the traditional way, but it is adopted by IUPAC. That's how the methyl group will be named. So it could be like this: CH2, 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 CH3. This is normal. This is CH2. This is isobutyl. If it is like this, CH3, CH3, CH3. This is neobutyl. That's how it will be named. Now let us try few of the examples how to work it out. These are the compounds you need to work out. I'll sort it out. You have to write down all this and write the name. So ethanol, propanol, this is basically an ether. So you could see the way it is naming. First root word will be written, then primary suffix, then the secondary suffix. That's how it goes. Eth, ane, nitrile. Here eth, ane, e will be replaced by all. Then here eth is the root word. Eth is the root word and amine is the functional group, but ethanamine, because the primary suffix is must. This is not an organic compound actually, it's an ionic compound. Its name is sodium methanoate. So methanoate, methyl ethanoate, this is a organic compounds, and it's very sad to say that the nitro group is still in front of the IUPAC office in order to get recognized as a functional group, but still it is identified only as the substituent. There are three people, they are identified as substituent only. One is nitro, the other one is halo, chloro, bromo, iodo, fluoro, and the other one is ether. Ether is not treated as a functional group. According to IUPAC, it is still treated as a substituent. So the name of the nitro group, then there is CH2, it is called as ethene. Then CH, triple bond CH, it is ethyne. You could see the pattern. Then this is prop, YNE, propine. And this is having 1, 2, 3, 4, 5 carbon atoms. So pent, pentane, E will be replaced by ol. That's how it will be named. So I am giving you a set of questions. This is in-class work. You have to write down this question and you have to answer to this question in a white paper, and you have to take a picture of this paper by PDF scanner and upload into Google Classroom. So these are the questions. So this is how the organic compounds will be named. So there is a root word, there will be suffix, and there will be prefix, and the root word will tell you about the longest continuous carbon chain. Secondary prefix will tell you whether the compound is saturated or unsaturated, and the primary the primary suffix will tell you whether the given compound is saturated or unsaturated, like Ane, Ene, Yne, and the secondary will tell you which is the functional group, what is the active part of this compound. And here the prefix, there are two prefixes, one is the primary one and the other one is secondary one. The primary one will tell you about, so the prefix could be primary or secondary. please understand that the primary will be coming, both the primary will be coming adjacent to the root word, and the secondary will be coming away from the root word. And the secondary suffix is about the suffix, and primary will tell you whether the compound is cyclic. If it is not cyclic, keep quiet. You don't have to say anything. If it is cyclic, you have to mention. And if it is secondary, it's about the substituents. We are taking few more examples to work out. So the first compound, it could be named. So there are 4 carbon atoms in this. So the root word will be but, and there is only the single bond over here. So you are supposed to write A and E. I am not writing E because that E must be replaced with all, because it is butanol. And the next one, it is carboxylic acid. So there are 4 carbon atoms. So here also you are supposed to write but, it is butan, and you need to add oic acid. Then here there are only 3 carbon atoms. So you are supposed to write prop. So propan, E must be replaced with ol, propanol. Whereas if you take the last one, it has got a speciality. What is that if you ask? It has got 2 functional groups. One is OH, the other one is carboxylic acid. Then how will you write? So you need to start with the root word, that is but, and here 2 functional groups are there. When there is the presence of more than one functional group, you are supposed to take one of the functional group as the principal functional group. Principal functional group. It's already given by IUPAC. According to IUPAC, COOH is the having highest priority. It goes like that. So if you take the COH and OH, the first priority goes to COH, that is oic acid. So you need to write butanoic acid, and this hydroxyl group will become a substituent, and you need to give the position also. This is 1 and 2, so it is 2 hydroxy butanoic acid. That's how it must be named. One more task. You have to have a A4 sheet paper, very neat paper, and you have to make a table where there are 1, 2, 3, 4, 5 columns. And the first column you have to put the number. Second column you have to put the functional group. Third column you have to put the structural formula. For example, I am taking, this is not the first one, I am writing just for the example. Suppose number 4 I am writing. The functional group is, you have to write its name, alcohol. Alcohol means its structural formula is OH, and if it is a prefix, the term will be hydroxy. You have to put a line. Then if it is suffix, it is supposed to be ol. So if it is the main functional group, you have to write ol. If it is a substituent, you have to write hydroxy. So what you need to do, you have to include all the organic functional group in this table, and you have to write it in an A4 sheet, take an image of that, and you have to upload into Google Classroom. And that is the criteria for your attendance. And you need to submit it to the same link previously you have submitted.